going to be presenting to you about some research, not very different from what Brett and Amy presented. I'll talk to you today about a project we conducted here in North Carolina. Myself and a great team of collaborators, you see them on the slide here, with funding from the Pork Checkoff National Pork Board to really help us understand the same technology, the shallow burial with carbon, and specifically to help us to respond in a disease outbreak situation, especially when it comes to swine production here in North Carolina, higher density of production. So the need for a timely response is critical. Another reminder, this is really what the technology looks like briefly. Not entirely below grade, slightly mounded with the carbon layer below to help with the leachate absorption and covered with soil. And this process so far has been put forward or studied primarily as an emergency response, not as a routine management, but specifically for an emergency response. And that's really a critical point that Dr. Schmidt touched on, is that in cases when such an event happens, there's a critical need for a lot of carbon really quickly. And with higher density of animal production, good quality carbon, more absorbing carbon runs out quickly. So the question becomes, what is the relative performance of the different carbons that we have available here in performing as a liner material in the shallow burial for carbon? So this really was the main question we set out to answer. A secondary question was, how does the status of the carcass, whether it is a whole carcass or a ground carcass, will impact the breakdown of the carcass and the leachate movement and the temperature inside the carcass. So we set out to conduct this study in the field, and we picked a site in Sampson County, which is representative of where most of our swine production takes place in the coastal plains. And we conducted that work at a research station, the Horticultural Crop Research Station here in North Carolina. The site specifically we picked up, we actually got to check the status for that site. One of the challenges we have also in North Carolina is because of we are low-laying lands and easily waterlogged. So it becomes sometimes challenging to identify really good soil to deploy this technology. And that's one of the main questions we're trying to answer today. And a quick aside is that using the soil survey on NRCS website, you can actually check the site suitability for this particular process. So it has been added to the catalog of technologies that you can screen for. And you can see the rating here between somewhat limited and very limited because of being a low-laying and primarily wetland areas. What you're seeing is the types of carbon that we have used in this study. We've used four types of carbon. Left to right, you are seeing a hay, primarily fescue. We use wheat straw, corn stover, and hardwood mulch. Again, hardwood mulch has been mentioned before, not the greatest, most absorbing material, but is typically available here with the logging and with the road clearing trees, so it might be considered. And we used all these four in a complete experimental design like you see here. On the right-hand side of that slide, you're seeing the colored panels represent the layout. If you're looking aerial down on the site, the column, the yellow represents the yellow, green, and orange blocks represent the time where the blocks were excavated. We looked at four types of carbon, 1 to 4. That's the coding for the material. And we coded whether the carcass was whole or macerated or ground as A and B. And each combination was also was replicated 4 plots at every time step. So as a total, we had 72 pigs, and they were laid out in that configuration that you're seeing. What I'm showing here is what the carbon looks like. These individual plots, we had the pigs buried individually, so it was not a trench with multiple pigs. In this individual plots, they were 2 feet deep, 3 foot wide, and 6 foot long, and the 2 foot depth was filled with the carbon. Because of the relative density of the material, the amount of carbon actually varies depending on whether it is hay, which is very bulky, and therefore the mass actually filled might not be as high as hardwood mulch. Moisture content was also another variable that would change the actual amount of carbon there. And on the right-hand side, you're seeing the picture showing the after the carcass was placed and a temperature probe that was placed on top of it. Again, hindsight 2020, that was a very challenging temperatures probes to recover a scavenger hunt when we had to dig them up 3 months, 6 months, and 12 months after the experiment. But we've recovered more than 90% of them. So we were able to conduct our temperature analysis, not 100% recovery. We had issues with some of them as well in terms of the operation. What you're seeing on this slide here is the top grinder that was used to macerate and ground the mortality. And similar to what Brett indicated, it created not a very uniform mixture, but it was fairly ground compared to what the whole carcass burial plots looked like. This is the data that we collected. We tracked carcass temperature and we analyzed the carbon at the termination of the study 12 months later. We also assessed the decomposition extent or the degree of decomposition. And I'll talk about that briefly after that, as well as soil column nutrients. So we were not collecting leachate, but we were digging a soil profile like you see on this picture here on the right, 4 foot of soil, and the gradation represent the unique samples. So 6-inch, 12, 24, 36, and 48 representative. So each of those will allow us to track the gradation or the downward movement of the nutrients. We only analyzed the nutrients in the plots that were excavated 12 months later. So we were not tracking soil at the 3 months or the 6 months. When it comes to decomposition, we looked into a criteria that have been established before. So this criteria using a numerical scale between 1 and 5 to represent the decomposition, with 1 representing a minor decomposition, flesh, hide, hair, fluids visible, basically very poorly decomposed, as opposed to 5, scoring of 5, where as a ranker or a scorer, you would look for no flesh, hide, or hair to be able to score it as a 5 on the decomposition scale. So we had observers at every time step in our study. Those are 3 months, 6 months, and 12 months. And those scorers or rankers were instructed on that heuristic or metric to analyze the decomposition. And then were also instructed to not share their ranking with one another as they go. So each individual plot was ranked between 8 and 10 times by 8 individual or 10 individual rankers. And those were used and analyzed in our results. Moving quickly to our results, and I'll start with the site. What you're seeing here, that's the site a week after being set up. We started in July 23. We dug some plots, the 3 months plots in October, 6 months in January, and the 12 months in July 2024. What you're seeing here on this slide is the rainfall at the site. The site also has a weather station, part of the state climate network. So we've relied on it to track the rainfall. And you see cumulatively, we had around 48 to 49 inches cumulative rainfall. It was pretty much a lot of rain, including November, which was unusual to get 7 inches of rainfall in December. So what that resulted in is having a fairly saturated soils for the duration of our study. For the soil classes we have, we were at field capacity around the 23%. So we were, for long stretches of the study, at saturation. What I'm showing here is the temperature profile. So this is for a combination of corn stover lined, buried carcass that is whole or completely intact. And what you're seeing here are multiple temperature. So the light gray, the dashed gray line represents air temperature during that period, average daily. And the dashed black line represents the soil temperature during that period. And the solid black line represents the average carcass temperature, and the gray shading represent a standard deviation above and below. What I want to draw our attention to is the difference at the beginning. During the first 2 months, we had temperature greater than the ambient soil temperature, but that difference quickly dropped. We did not achieve the 130 degrees that we typically shoot for composting standard temperature time. Um, we also noticed a trend when you compare the same type of carbon, but with the macerated or a ground carcass. You can see a slight increase in temperature at the beginning, but we see no increase in temperature in the last 6 months, which we have seen in the whole carcass. That indicated to us that there was some degradation that was still taking place in the latter part when the soil started to warm up again, whereas with the ground carcass, most of the decomposition has already taken place early on, and therefore there was no temperature rise to happen again in the next summer. We noticed the same trend here with wheat straw. As you can see the difference between whole carcass and ground carcass. When we talk about the decomposition ranking, I'll show you some of the visual here. So on the left-hand side, you can see a whole carcass and ground carcass at 3 months that is lined with hay fescue. I want to draw your attention also to the color of the soil. You can kind of see that this is the wet brownish color of a saturated or wet soils, which what we have seen at multiple time steps. That's in October here. Here in January, you can see the soils clearly. Here is in the following summer. So you can see some of the extent of the degradation. Here you can see visible flesh and fat that is still visible 6 months in, and then it starts to disappear a year. Again, we are not covering and digging the same plots. The plots that have been excavated at 3 months has automatically stopped being part of our study to make sure that our excavation and covering does not bias the process. To show you the ranking or the scoring here, this is a very busy chart, but I want to orient you. What you're seeing here are rows representing the time. So this is the 3 months, 6 months, and 12 months. And the left side here representing the whole carcass. Right-hand side is the macerated carcass. And then 1, 2, 3, and 4 are coding the hardwood mulch, corn stover, wheat straw, and hay, and the same pattern repeats here on the right. What the graph is representing, the decomposition scoring, so it's 1 to 5, as you can see here, and the actual representation shows the odds or the probability that this particular combination of carcass and carbon material at that timestamp is ranked that value. What that means is, for instance, if we started at the top left panel, a hardwood mulch with a whole carcass at 3 months, that means that the highest probability is that for it to be ranked 2 on the decomposition scale. Second most probable is ranking of 1. It's very unlikely to be ranked greater than 2. Whereas if you contrast that with a B4 here, that is a ground carcass lined with hay at 3 months, you'll see that the most probable ranking for it would be that it is a 5 on the decomposition scale, most fully decomposed, or partially the second most probable would be almost fully decomposed. So that ranking can help you see here on the left-hand side, we see most of the carcasses were ranked under decomposed or less decomposed than ground carcass. And you can see as you move downward for the same panel that we are capturing the decomposition of the effect of time on the decomposition. And you can see here when we track the same carbon type across the status of the carcass, whether it is whole on the left or ground on the right-hand side. We also managed to pick a statistical effect of the ranker, and that's what you're seeing here in front of you. It was evenly distributed around the 0, which allows us to conclude that there was always with the subjective ranking, you'll have some, whether subjective, always underscoring or overscoring, but overall, we believe that we've captured a balanced panel that allow us to have a representative decomposition rank of what we saw. I'll briefly show you some of the results of what we've analyzed. We found nitrate, we tracked nitrate, ammonium, and orthophosphorus. And what you're seeing here is the table showing what was statistically significant. So the axes here represent what effect was significant from a statistical perspective. We start with the nitrate because it's the most relevant to groundwater quality. We saw that hardwood mulch, by and large, actually was associated with the lowest concentration of nitrate below, which was very interesting that we would expect a corn stover or a high absorbing material, but then the hardwood mulch actually was associated with the lowest concentration of nitrate in the soil column below it. And that might be associated with the surface chemistry or its ability to attract a nitrate molecule, a negatively charged nitrate molecule, and thereby reducing its downward movement through the soil column. For the rest of the carbon material, we did not really see a statistical difference between them. This is what you're seeing here is the depth effect with the highest concentration in the top 12 inches and quickly the effect of depth diminishing. We saw a similar effect with the ammonium concentration downward. We saw the effect happening mostly in the top 2 feet, and quickly with the third and fourth feet, there was no statistical difference between them, and they were much lower statistically than what was before. Both of those are indicating that most of the nutrient movement was intercepted and limited to the upper 2 feet below the carcass burial plot. We also saw a close effect of the grinding of the carcass on the downward movement of the orthophosphorus in particular. We saw that the carbon material did a great job of absorbing the leachate below the carcasses, and the concentration increase of phosphorus as a result of the deployment was the greatest under the ground. So that's telling us here how many times the phosphorus concentration increased as a result of being used as a liner under buried carcasses. So you can see corn stover, for instance, the concentration of phosphorus really increased under ground carcass compared to whole carcass. Hardwood mulch in particular saw a much greater absorption and therefore increase in phosphorus concentration compared to being placed under a whole carcass. We observed in our study also a lot of biological, vector activity early on in our trial. And it required some soil replacement, but after that, there were just nosing around, but there was no signs of actual material being excavated and removed by animal in the site. So to wrap up, we really saw some temperature increases. We nowhere achieved anywhere near what we need for a temperature deactivation. We saw decomposition to be critically dependent on the carcass state, burial plot, burial period, and finally on the type of carbon. And we saw that ground carcasses will increase chances for nutrient downward movement. Downward movement of nutrients has been limited in an upper part of the soil profile. With that, I want to acknowledge the team that worked on this and take any and all questions that you have for me here.